chapter 14, we're looking at linear approximations. We're going to use the tangent line to approximate values of the function. And in order to do that, we need to look at this idea of the tangent line and how we get closer and closer to the point, what happens to the tangent line and the function. So we've talked about in the past that the tangent line, if we were to zoom in, is going to look almost very closely resemble this y equals f of x curve. And we can see that here. The further out we get from that point, so the further from this point that we get, say like way out here, that approximation is not going to be very accurate. But if we're approximating something really, really close to this point, x equals a, our values are actually going to be pretty accurate at that point. So we're looking at here, this first part talks about the left side kind of looks like a circle, but it actually has 24 sides. And the more sides it gets, the smaller each side gets. And the closer that circle or that polygon looks like a circle. So the calculus definition of a circle is simply a polygon whose number of sides approaches infinity and whose lengths of each side approach 0. So like wooden roller coasters use this as well. It's not just one piece of wood that's been bent. It's actually a bunch of smaller pieces of wood fit into that curve. So suppose we have a function f of x, its tangent line drawn at the point as shown in the right. So what we're looking at here, we're really just looking at y minus y1 is equal to m times x minus x1, where this x1 is the point, x1 is the point equal to a, and y1 is that value that we get when we plug in a. So what we're really looking at here, this is really just the equation of the tangent line. And we can use that to approximate values. It's called linear approximation. And the questions are going to be worded something like this. Use the tangent line or use the linear approximation of f of x equals, they're going to give you a function, add x equals a number. They're going to ask you to evaluate or approximate f of some value. So in this case, we're actually approximating f of 8.1. So what is f of 8.1? What's the cubed root of 8.1? We don't know what the cubed root of 8.1 is. Without a calculator, that would be very difficult to actually calculate. It's a little bit more than 2, but how much more than 2? So the first thing we need to find in this case is the equation for the tangent line. And in order to find that, we first need to find the derivative. So this is really x to the 1/3. So the derivative of that will be 1/3 x to the negative 2/3, which is equal to 1/3 x to the positive 2/3, which is equal to, I know I'm going to have to plug in 8 in just a second. So I'm going to switch this back to radical form. The 2 is the exponent. We can put it in one of two places. We can either put it here or here, whichever one benefits us the best. At the moment, I'm going to leave it outside and then the cubed root of that. So now we need to know what f prime of 8 is equal to. That's going to be 1/3 times the cubed root of 8 squared. So we can either square the 8 first and get 64 and then take the cubed root of that, or we can take the cubed root of 8 first, which seems a little bit easier in this case, which is 2, and then square that value. And we get 1/3 times 4, which is 1/12. So the equation of our tangent line, or the slope of our tangent line in this case, would be 1/12. So y minus this y1 piece, we're going to plug 8 back into f of x. So f of 8 would be the cubed root of 8, which is just 2. So we end up with y minus 2 is equal to 1/12 times x minus 8. So we're using the tangent line at x equals 8 to approximate the value of the cubed root of 8.1. And this is called linear approximation because we're using a line. the tangent line. So we can make this look a little bit nicer. We could multiply everything through. We can distribute the 1/12. So we get y minus 2 is equal to 1/12 x minus 8/12. And then we're going to add 2 to both sides. And 2 would be 24/12. So we get y is equal to 1/12 x. 24 and -8 is 16, so plus 16/12. And I left these fractions the same. And since we left these fractions the same, we can actually combine this into one fraction, x plus 16/12, since we have common denominator. And now the idea is that we're going to use this. If we were to look, x plus 16/12, that's this line right here. And we're going to use that to approximate the value of 8.1. So if 8's right here, 8.1 would be about right there. So what would that value be equal to? So the approximation, y, is approximately 8.1 plus 16 all over 12. And 8.1 plus 16 is 24.1. So we get approximately 24.1 over 12. To do this without a calculator would not be super simple, but we end up with 2.0083. Yeah, I'm trying to think of how we could do that without a calculator, but I'm having a hard time trying to figure that out. It's possible, but all right, number 2, use a calculator to find the error in using. So let's go back up. This right here, this number right here is not exactly the cube root of 8.1. If we were to type that in a calculator, we could figure out what exactly the cube root of 8.1 is. You can hit the math button on your calculator. You can go down to number 4. The cube root of 8.1 is 2.00829. 829,885 if I write down every decimal place. So we see our approximation is actually really close to the actual value. All right, number 2, use a calculator, find the error in using the linear approximation. So f of x equals e to the x at x equals 0. And we want to approximate the 4th root of e, or e to the 1/4 power is what we're trying to approximate. So we need the equation of the tangent line. So we need f prime of x. F prime of x is, well, just e to the x. And we need f prime of 0, which would be e to the 0, which is equal to 1. So that's going to be the slope of our tangent line. We also need the y value. So if we were to plug 0 in, f of 0 is e to the 0, which is also 1. So we get y minus 1 is equal to the slope, which is 1, times, not m, times x minus 0. And we end up with y is minus 1 is equal to 1x plus 0. We add 1 to both sides. So we get y equals x plus 1. And then we can plug in 1/4 to that because we're trying to evaluate at x equals 1/4. So our approximation, e to the 1/4 is approximately 1/4 plus 1. And 1/4 plus 1 is 5/4, or 1.25. 5/4, which is equal to 1.25. And now what they want us to do, they want us to use our calculator to approximate the error. So this is the approximate value. We're going to find the actual value. So in the calculator, we can type in e to the 1/4 power, or the 4th root of e, whichever one you would like. E to the 1/4 power is approximate, or is equal to 1.2840025 if we round to that much. And then to find the error, we would actually subtract these two numbers. 1.284, actually 1.25 minus 1.284 if we round to 3 decimal places. 1.25 minus 1.284 is negative 0.034. So that's how far the actual is away from our approximate value. And notice we found that approximate value without a calculator at all. We didn't use a calculator at all. But finding the fourth root of E with a calculator, not hard, but finding it without a calculator would be very, very, very difficult. Very difficult to do that without a calculator. So we can actually use this to approximate values that would be difficult to find. This would be easier back in the old days when they didn't have calculators to approximate those values. But now that we have calculators, this almost seems like, why would we do it? But it is an application of the tangent line. All right, number 3, for the tangent line to f of x equals x squared minus 3x plus 5 at x equals 4, we want it to have an error of at most 0.1. So this is an inequality that we're setting up here. In approximating f of 4 plus h, what would h have to be in this case? So the first thing we need is the derivative. The derivative would be 2x minus 3. And we need this derivative at x equals 4. So we need f prime of 4, which would be 2 times 4 minus 3. 8 minus 3 is 5. So that would be the slope of our tangent line. We also need f of 4. So if we plug 4 back into the original equation, we get 4 squared minus 3 times 4 plus 5. 4 squared is 16. 16 minus 12 is 4. 4 plus 5 is 9. So now we can actually come up with the tangent line. So tan line. So y minus 9 is equal to the slope, which we found to be 5 times x minus 4. We can distribute the 5x. So we get y minus 9 is equal to 5x minus 20. We can add the 9 to both sides. So we get y equals 5x minus 11. So now what we want this 4 plus h. We want to basically see like how far can we go away from this point x equals 4 and the error still be less than or equal to 0.1. So what we're looking at here is this idea of an inequality. This gets kind of yucky, but let's see what we got. We end up with f, let's write it over here so I have room, f of 4 plus h minus, so that's going to be the actual value. This is the actual value, and we're going to subtract the approximate value. The approximate value is going to use the tangent line, which would be 5 times 4 plus h. Why did I put an x there? I need to put an x there. 5 times 4 plus h minus 11. We're using the tangent line for that, and that's in parentheses. And we want that to be at most 0.1. So that's got to be less than 0.1 in this case. Erase, give myself a little bit more room here. And then we end up with f of 4 plus h. So we're going to plug 4 plus h into our original equation, f of x. So we get 4 plus h squared minus 3 times 4 plus h plus 5. That's going to be the f of 4 plus h piece. And then we can distribute the negative. So we get negative 5 times 4 is negative 20. Negative 5 times h is negative 5h. And negative 11 is plus 11. And we still want that to be less than 0.1. All righty. Do some multiplying. 4 plus h squared would be 16 plus 8h plus h squared. Distribute our negative 3. We get negative 12 minus 3h plus 5, and then minus 20 minus 5h plus 11, and that's still less than 0.1. So we're solving an inequality at this point. Let's see. We can combine some like terms, and we end up with, h squared is the only square term we have. We have an 8h, a negative 3h, and a negative 5h. Those actually cancel out. We have a 16 minus 12 would be 4. 4 plus 5 would be 9. 9 minus 20 would be negative 11 plus 11. So all of those actually cancel out too. So we get h squared is less than 0.1. That was really nice that all of those numbers that didn't have an h canceled out. So we get h squared is less than 1. We take the square root of both sides. So we get h is less than 0.316. So any number between 4 minus 0.316 and 4 plus 0.316 that we would approximate would have an error of at most 0.1. And we are done with chapter 14. The idea of chapter 14 is really just this idea that can we find the tangent line and then use that to approximate values. So plugging in like this, plugging in 2.5 without a calculator, 2.5 squared minus 6 times 2.5 plus 12, like that would be hard to calculate without a calculator. But if we find the tangent line, y equals mx plus b, we can then plug 2.5 into that. Obviously, we would know what m and b are once we took the derivative and stuff, but that's going to be a little bit easier to help us approximate this f of 2.5 piece. This is chapter 14 from Master Math Mentors AP Calculus AB Manual. If you have any questions, please let me know, and I'll be happy to help you out when I get a chance. Have a good day.